Okay. All right. So let me just quickly say that we've been working over the last several years since the 2.5a release to implement a number of changes in DIGGS. There's a whole lot of things that have been worked on. A lot of changes are under the hood. The one rule that we've been following with 2.6 is that the changes we have are backwards compatible. That means that if you have existing 2.5a instances, they will validate again under version 2.6. There's a whole slew of things that have been changed under the hood. One of the major ones in terms of the main part of the schema is that we've updated to the version 2.0 of the Energistics and WITSML units dictionaries. So we have a more enhanced set of unit definitions. We've added additional units types to that. There's several other issues on GitHub currently that we'll be working on to get those completed as well. We've been generally cleaning up a lot of orphaned objects. A lot of additional documentation is going into the elements. And some redundant or poorly defined properties have been deprecated in 2.6. Those properties are still there, but they've been changed to other versions, and those are explained in the documentation. The other thing we've done is added several new geotechnical test procedures. The dynamic probe test, point load tests, and pore pressure dissipations are new. And then the major new additions are in adding support for process geophysical data and for support for grouting activities in boreholes. So for the grouting, this has been an effort that's been going on for several years. This slide is a diagram, a high-level UML diagram that shows all the top level, what we call the major object class components, and how they're associated. Essentially, a DIGGS instance is a collection of one or more of these of objects that fall within these major object classes, depending on the types of information that's there. And the way DIGGS is built is in this sort of modular fashion, so that we can fairly easily extend the schema without breaking things that are already in the system. For grouting, we have produced two new top-level items. These are the ones in pink. We call them program and construction activities. DIGGS prior to grouting was all concerned with exploratory data, but we're now delving into the construction aspects of geotechnics, starting with grouting, but we can be extending within the construction activity object class into pilings and other types of construction activities. So we're just starting with grouting now. The program element is used for defining specifications and design for construction activities. Again, DIGGS up to this point was always talking about or referring to objects and tests and information that already existed. But when we start talking about construction, there's generally a design phase with specifications. This is the program place is where those specifications can go to then be compared against the results of the construction activity, which is where the actual sort of construction data goes. This construction activity object class, these are a bunch of the different new objects that have been built so far. There's a main abstract construction activity class that is where everything inherits from. We've generated a single concrete activity for what we call linear grouting activity. This is grouting that's done in a borehole or in linear columns or panels. There's two component objects to that. One of these, called the grout stage, is used for rock compaction and permeation grouting. The other piece, what we call continuous grouting, is for the jet grouting and deep soil mixing activities. And the data that's collected during these activities are primarily in time series, the injection time series for which you can have several of them per grout stage, or the grouting time series for which you can have several in the continuous grouting type. There's other pieces and objects that are attached to that. We've developed a whole bunch of new specialized equipment objects for being able to specify characteristics of the grout pumps, the grout plant, jet grouting monitor, etc. And also, we've extended our sample object to contain information for grout batches. So the details of the grout mixes can be identified and then referenced by the grouting activities or the grout stages. And also grouting fluid characteristics with respect to the fluids that are used in the jet grouting deep soil mixing activities. These are the types of data that could be that's managed under the injection time series. We have a means of compactly encoding the time series data so that a lot of information can be stored relatively compactly. So for these are some injection time series for rock grouting activity. The grouting time series, this is an example from jet grouting with both the downward and the upward, both the withdrawal and the insertion and the withdrawal of the monitor. So there's the depth that's going down through time, along with the RPM and the drilling speed for the drilling, and then once we're coming back up and injecting the grout pressures and rotary pressures can be recorded along with the depths. So large amounts of data can be handled with this approach. The program object class is the part that has all the stuff about the planning information. We've developed a number of objects to handle grouting specifications, both mixed grout soil and the grout itself. Grouting activities such as the target depths and target pressures and target strengths, and that's the target strengths and that sort of thing would be part of the grouting performance. We've also have grout design information, and the yellow box is a to-do for being able to identify grout layouts, borehole layouts, and that sort of thing. So again, this is the beginnings of that part. Speed up.
Can we kind of move along into the geophysics?
Yep.
Kind of run.
Yep. Grout test procedures are new ones that we've also done. So the geophysics is the other part of this. We have now have to work with in geophysics with measurements that are indirect. So we have a number of challenges. In addition to that, there's also large data sets. We've decided to focus on being able to transfer process geophysical data as opposed to the raw data files. That will be part of our next phase. So in 2022, the deliverables we produced, there's a number of new sampling features that are able to now handle data that are in 2D and 3D spatial domains. So we can create, for example, dogleg type sections, such as this cross section that's representing here resistivity data, or map view data in 2 dimensions. So we have elements that can then define the geometries of the reference edges and the offset vectors, so we can essentially create planar features with any sorts of orientation. We can also deal with 3D volume spaces, where we can define the 3D space with a series of offset vectors that can define any point in space, along with with polygon constraints, solid surface constraints for the shapes of the 3D features. We also have developed a new test procedure where we can identify the particular type of geophysical approach, geophysical technique that's being used, and descriptions of the processing steps that were undergone to convert the raw data to the process information. So again, we're not carrying the raw data yet. That's part of the next phase, but we can at least identify the processing steps that were taken to go from the raw data to the process data. And also, because of the large data file sets and the fact that many of the data sets from the process geophysical data is gridded, insofar as that the information is regularly spaced, We've adopted a GML grid object to be able to use that to define the locations very compactly. So we can essentially define lower and upper limits of a grid, the offset vector distances between points and their orientations, and within just a few lines of code, be able to define the locations for thousands and thousands of data points. So this is another way to try to reduce the size of the DIGGS files. All this stuff is all up on GitHub in version 2.6. This coming year, we're going to be working on data acquisition measurement objects, looking at the raw data and how to transfer that, developing compound coordinate systems so that we can deal with spatial temporal data, for example, for use for seismic time sections or time volumes. In addition to being able to develop some objects to be able to carry binary data as well. So that's it for the geophysics and for the grouting. So those are the two main, or all the main parts of the new things that are in 2.6. Okay.
Cool. Thank you. You want to make a quick comment, or maybe Derek wants to comment on the interoperability experiment? Go ahead, Dan.
Me?
Yeah, sure.
Sure. Well, so the Open Geospatial Consortium, which is an international standards body that is, they're the folks behind geography markup language. They also have overseen a lot of standards definitions in the earth science industry, GeoSciML and WaterML and a number of other ones. Is looking to dip its finger into geotechnics and is looking to adapt their observation and measurements standards to be able to accommodate the geotechnical data and to be able to use that as a way of interacting between various different other data standards such as DIGGS and AGS. So we've been invited to work with them on that interoperability. To the way through the process. Can you hear me? Whoops.
Yep, just came back.
Oh, I'm back. Okay, sorry. So I was going to say that the OGC has been running these workshops with a fairly large group of folks from all over the world in sort of developing what we're looking at developing a conceptual model for the various objects that are needed to carry geotechnical data, and to be able to meld that within their existing observation and measurement standards. So DIGGS is involved in this, along with AGS, along with the IFC Tunnel Project, MineMD, a number of other groups and organizations that are all dealing with geotechnical data. And the idea here is to be able to have a kind of an overarching set of concepts that all of us can work towards making sure that we deal with in our own ways, so that it will ease the burden of being able to move information from one data standard to another.
Cool. Thank you. Derek, you want to mention a few things about MWD?
Yep, and just a quick add. So in addition to the GI special project to expand the DIGGS schema for geophysics, there's also another project to expand it into measurement while drilling. So we're hopeful that the folks who are currently working on creating a US standard, that effort will go along in conjunction with the creation of the standard or MWD information within DIGGS. And that way the standards can then also mention DIGGS in the process of doing it, and we can develop language so that we can transfer it using that standard. And I think, Scott, you had said that most of the information, if not all of it, is...
All of it is in there. We just, moving forward, we need a more compact way of storing it, because it could be very large files.
If we can figure out how to compact geophysics and instrumentation, I think we can.
Yeah, we know how to compact it. I mean, Dan and I have been posting about it on GitHub, and
yep,
we know how to do it. It's just, that'll be in 2.6, I think.
We'll talk more about the GitHub site here in a minute, but if anybody's getting notices from that. You got a whole lot of them this morning, Dan and Scott. All right. Just a couple words about the documentation and vendor engagements. Again, this is another one of the GI's committee special project funds. So the geophysics phase 2, the MWD, the documentation and vendor engagement are all projects funded by GI, much appreciated. Documentation, Dan has drafted up the first version of the RFP, so we're hoping to get some more streamlined, compact documentation to make it easier for folks to start using and programming DIGGS. So hopefully that'll come together this year. We're outsourcing it instead of looking for volunteers, so maybe we'll make progress there quicker. I wanted to talk or open up the floor a little bit for the vendor engagement part, because this is really exciting. We're engaging with numerous data providers, vendor providers of data, and I want to recognize all the DIGGS people that are kicking in and lending a helping hand to help provide the guidance and support as these vendors do this. Many of them are sitting here in the room, or most of them are sitting in the room. Derek and I are just ushering this through here. So, but anyway, that's who's involved. But I was going to give each of the folks that said they had something to chat about a second to tell us what they are planning to do with DIGGS in this coming year. So I'll turn it over to Elarez with RS Logs first. Say a few words. Are you there? Yeah, he's there.
Hello. Yes. Yeah. Yep. Thanks very much. Yeah. So as you mentioned, what we've done in 2022 is that we've added a feature to RS Log, our borehole logging software, to read from DIGGS, and the screenshot you see is essentially the mapping tool that we have in RS Log to load a XML file. Map. We essentially by default we map some of the fields to RS Log database, but user has some flexibility to change the settings. At this stage, what we load is general borehole data like a stratigraphy, groundwater level, depths, and so on. And also we import some of the lab tests, simple lab tests, algebraic limits, sieve test, classification, that type of information if that exists in the XML. Yeah, this is an example of the integration between. So we also designed an API that is called by GeoSeta website. So in GeoSeta, we know that there are a lot of data. I leave this to Ross to explain, but they in GeoSeta they export borehole data to XML and they pass it to us. And we're using this API. What we do, we just convert that DIGGS data into a borehole log, and you see in the screenshot on the right side an example of this borehole log generated from GeoSeta DIGGS file.
Awesome. So we're finally not at the chicken or the egg. We're at the chicken and the egg stage. Things are moving along. Thank you very much for that.
Yeah.
Kava, you want to talk a little bit about GeoComp's efforts this year? Oh, there you are. Okay.
So, we may have to come more closer. You should come up.
Here.
Okay. In late 2022, we got engaged more seriously about this and basically decided to put a team together and put a plan. But now the plans are in place, and we're hoping to have our software, automated testing software, prepare report that supports DIGGS accepted format. We're going to start with UU, UC, and simpler tests and expand it to more complicated tests. And appreciate all the feedback and help that the folks here have agreed to give us.
Thank you. Very exciting. Scott, you want to take over and show a couple things? Roger, you're next.
Okay, so data forensics has been running with DIGGS for quite a while. We are going to be officially releasing our DIGGS converter for Open Ground. this year, and that will include support for version 2.6 as well. So we've been playing around with that. It's coming along. Lots of great improvements that Dan has been very helpful moving forward.
He's retired and has all this time now.
Exactly. I think he has a full-time job. We are working with various equipment manufacturers to facilitate the workflow, because really our goal is we want everybody to have access to all the data that they're collecting. So we had a meeting with LIM back in December, who's a measure while drilling manufacturer, and we had created an example file that we went through and kind of honed that into, okay, these are the things that you guys have in your software. So gave them basically a simple example that's their template for them to start producing the MWD data files. So hopefully that will move forward. Obviously working with the lab manufacturers, can't wait to get that going, and CPT manufacturers as well. So lots of promoting, getting the manufacturers to produce the data that we can consume.
It's all great. This is going from the very beginning of the data creation all the way through the presentation, which is the whole concept behind DIGGS from the very beginning. So it's exciting times.
Yeah.
So, is that a video or something you want to show?
Yeah. So here's just a short little video. Basically, we have a DIGGS file that we consume in the DIGGS converter service, and that goes directly into OpenGround via their API. So basically, you just go to a website, you upload the file. Currently, it's only 2.5 because we haven't released 2.6 yet. But upload the file. I think it's done. Maybe not. There we go. So we're going to name a DIGGS file, upload the file. This is an Ohio DOT example. We've been playing around with Ohio DOT data and also data that we have been generating directly from OpenGround. So we can basically go both directions. I think this example has borehole data, lab testing data, and in situ testing data. So a very comprehensive example. We have been working with all the unit conversion, hence many of the reasons why there are so many posts on GitHub, is that we are fully supporting all the unit conversion. So basically anything that has a unit in DIGGS, the unit conversion is supported in our tool with OpenGround. Once you've got your file in the cloud, we can go to either GEMS as a download, we can go to Wholebase as a download, or push it directly into OpenGround. So what we're doing here is actually that's connecting into your OpenGround cloud environment. And I got to find the project I'm working on and then select that. That's then going through all the OpenGround validation, making sure all the unit conversion makes sense, which that's been tremendous fun. And just to show that this is a live example that was pre-recorded. There is no data in this project in OpenGround. Literally all the data in all the different tables does not exist. But as soon as I click that button, and it does take about a minute, so I did edit that minute out because I didn't want to make you suffer through just waiting a minute for it to do it. So there you see, it has ended, and now we have data in OpenGround. So I'll open that project again, and then we will see that there are 3 boreholes, 3 CPT soundings, lots of geology data, discontinuity data, depth-related data, all over the place, in situ tests, lab tests, and then it's what do you want to do with the data? You want it in borehole logs, you want it cross sections, you want to analyze it in leapfrog, model it, whatever it is, show on the map, you name it, it's all part of the workflow.
Very good. Cool.
So, this is for Ohio DOT, right? Configuration pack?
No, they don't have a configuration pack. This is for our configuration pack.
If someone else has a different configuration pack, is it going to work? How do you do the mapping?
So yes and no. If you are using any of the standard core configuration packs in OpenGround that basically data forensics work with the kinetics group, it should work. Any configuration, we do have to do some additional mapping if you've added new tables or new fields, assuming they exist in DIGGS. So we can build new mappings to it if we need to. But
So from what you've seen, everyone is mostly using the same.
Yeah, you can't really change. You can't change the core table names or field names in OpenGround. So it is what it is. Now you can add to it. So everything that's in there by default should work. Anything beyond that, like some of the stuff that AGS has done for AGS 4.1, where they've gone off the rails on fields that can be text and numbers. No.
The 1 minute or so that it takes to load, is that OpenGround?
That's OpenGround, yeah.
Is it going to get faster anytime soon?
Yes.
That would be a question for Bentley.
Just be happy it's working. Come on, man.
It's a minute.
I was talking about this earlier. Every time you make a thing, it's a, well, why can't it do this? Or why can't it do that? It's like, ah!
That speed is an issue. It really is.
That's true. It used to take half an hour to put in your CPT soundings.
Yeah.
And,
Now it takes
for
a
the boring
minute.
data. So,
Yeah.
God, what are you thinking with a minute?
I know. I mean, that was 3 CPT soundings. I remember when they were talking about it, you could push your CPT faster than you could process the data.
Yeah.
So,
I'm gonna go in there and I gotta restart it.
It wasn't that long ago.
yeah. So I'm happy with a minute, but Roger says it'll be faster.
All right. So, Roger, this is your chance to tell us how fast it's going to get.
That set me up. Thank you very much, everybody.
I guess speed is subjective, right?
It's a relative term, isn't it? Faster. Yeah. So a couple of things. Mainly, we have been working with Scott, who's shown all the candy, if you like, and shown what's possible now with OpenGround and DIGGS. We also put on quite a big webinar probably about a month or so ago now, focusing on using DIGGS data and other data with DOTs and federal authorities. We had about 200 people register for that, so that was a very well attended webinar promoting the use of DIGGS and showing some of the demos that Scott showed there on that. We are working on bulk importers at the moment into OpenGround so that data will go in faster. How fast, I can't tell you, but we are looking at some incredibly large files that are being put in at the moment, and also some snazzy webhooks technology that will allow people to do very cool stuff. So bulk importers being worked on for that. We're also still looking after the validation tool, if anyone happens to still be using that. I'm not sure if they are or not, or whether that has now reached the end of its life. I'll have a go at putting the PyDig stuff into that, which will be a nice addition into it. But yeah, apart from that, we're sort of quiet in the background, helping our third-party vendors writing cool stuff. And we hope one day maybe to link OpenGround with the GeoSetter stuff with Ross as well.
That would be awesome.
Well, there have been some conversations over the meetings about somehow importing DIGGS data into some of your application tools. You're still looking at some of those options as well?
Which particular application tools were mentioned?
Plaxis and GeoStudio and Leapfrog or whatever.
Yes, so now we're all sitting under the Sequent banner, which is the Bentley subsurface company. We're all effectively in the same team, and there's a lot of interoperability going on now. So once you've got the data into OpenGround, you'll be able to get it into all sorts of tools, Open Roads, Open Rails, all the way through to Plaxis and GeoStudio. Some of them are working at the moment, some of them are in prototype, but interoperability is definitely top of the list at the moment for getting data from OpenGround into any tool you like. I mean, Arup, we did a webinar of Arup about 4 months ago, where they showed some very cool stuff that they've integrated directly into OpenGround just using the API themselves. So yes.
Just to check, so do you have it set up so that you can actually go from a tablet inside of OpenGround Collector and then capture it, and then it will drop into OpenGround and you can save it as a DIGGS file? Has that been completed so that that whole process can now take place?
Yes, it's not automatic in the creation of the DIGGS file. From going from tablet to Open Ground now is. We'll also create a log dynamically as well, so give you a QA audit of who did what and when, as whenever you sync the data between the tablet and the cloud, and then anyone can go in and use either the exporting tools that Scott's got, or the feedback tool to generate a DIGGS file.
That's great.
All right, so let's keep moving. We're already behind schedule in the first agenda item, so I'm gonna be pushing here. Ross, it's your turn, but take it quick, please.
Yes, so I've been instructed to do this as fast as I can, so I'm not going to spend any extra time. All right, so I think we all have heard GeoSeta is a nonprofit company. We are trying to be a repository for all of the public data. I have the personal view that as a profession, we need to try to be maximizing the value of the testing that our taxpayers have paid for. So GeoSeta is not a substitute for site-specific investigation. We just don't want people to be starting from scratch. Okay. So we have created a repository, and this is, I'm very, very proud to say that we have over 100,000 points from 12 contributing agencies, and we are presenting all of our data in DIGGS. So that's one format, and the cost, we provide the GeoSeta tool and services for free for any public agency who's contributing data, and then thanks to our sponsors, everyone can view and download our public data for free through 2023, and then those who decide to support us, they can access additional tools that then use machine learning trained from all of the drilling history that GeoSeta has. So you see the states here who are contributing, and then I'll be showing a very fast preview of the tools and what we have. So you can actually go into GeoSeta, and we have a free DIGGS viewer. So this can parse the standard penetration drilling that has been saved inside of a DIGGS file to then view it. I plan to try to integrate Sheen's PyDIGGS, so soon you'll also see those results. So just to show you, I'm going to drop in a file. Here we go, and I'm going to process it, and it's going to complain to me that I need to sign in. Which, let's see. This is always what ends up happening whenever you go to do a live Thanks.
Well, Scott
That's why I
records
record videos. I used to do them live.
Yeah.
I'm tired of it.
Let's see. That's a smart thing to do. All right. Well, I grabbed the file right before, so that then generates your log that you then see the blows, the soil types, blah 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 blah. This is all generated on the fly, straight from the file that you dropped. So this is a huge thanks to Rock Science, and now we all have a way to view these files as logs. Yeah, and so I think that's about everything I was going to show.
Great, thank you.
Yep, I tried to go as fast as I could.
Good job there.
So what data so far, just lithology and SPT?
Yeah, so we are starting to put in all of the lab testing, and that's also cool because we are starting to train off of all of the lab testing. So soon we'll have more complex models for the predictions. So, yep.
Cool. So Ross, just a question on the log.
Yeah.
So does that connect to the company or contractor that actually did the boring? Or because it came from state DOT? It's all been sanitized.
It's all been sanitized.
And that's a conversation we're going to come back to here in a little bit under the roles, whether we capture that.
Yeah, so we are strict to sanitize out the driller and blah, 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 blah. So you just see the data.
So since you're asking the questions now, we'll let you do a little spiel on IDEA and geotech tools.
Sure. Thank you, Alan.
Timing's everything.
So I manage the IDEA program and geotech tools for GI. So thank you, GI and members of GI for that support. So I not really connected to DIGGS, but another tool that the GI offers for engineers, designers, academic students to understand geotechnology. So IDEA came out of the SHARP program back maybe 10 years ago now, I guess.
Geotech tools.
Excuse me, thank you, Silas. Yes, Geotech Tools came out of the SHARP program. The PI was Vern Schaefer of Ohio State, Iowa State, lots of other people involved in that. It's a success story for GI. They kind of graduated from federal funding. GI took it over and now is managing it, making sure the technology is viable, getting sponsors to ensure that we have some funds to do some work. And that Geotech Tools activity is all managed by the GI committees. So we're kind of very heavily involved in those committees. They review case studies. They also establish new activity for research projects to put new technologies into geotech tools. And we spend a lot of time at the Geo-Congress trying to get people educated on the program for geotech tools. Sir.
Jeff, I would love to have the opportunity. So on here, I did, I'm sorry. You see all of the points that GeoZeta has for all of the drilling history. I would be happy to have the opportunity to place also the geotech tools case studies on here. So
yes, we chatted about that, and we do need to follow up.
Okay. Cool. Awesome.
For sure.
It would be exciting to see that because then you could see the relationship of, well, this type of ground improvement worked in this area, so maybe it's something to consider, and maybe be able to link the actual subsurface data with it as well if we could start compiling that along with the case histories. So there's some opportunity there.
That's kind of
that was the original vision.
They're trying to help
That
people
wasn't the
pull.
original vision.
But things like you all have a valuable resource that
He agrees.
pull more value out of.
You're selling to somebody who is not selling.
I thought you were saying that that's not the vision, so therefore we shouldn't pursue that.
Nope, that's exactly the vision.
Okay.
So just that's geotech tools in a nutshell. Main audiences, really everybody. State DOT, academics, students, engineers, designers, even the public at large, if they were so interested. The IDEA program, on the other hand, that the audience for that are wall suppliers who actually participate and get their earth retaining systems evaluated, and state DOTs who are the consumers of that, because those suppliers want to be able to build their projects in certain states. So the IDEA program has come a long way from evolved out of the high-tech program. And so there's a lot of excitement there. That's also run by a committee within GI. Scott, I know you're involved. Silas, of course. Alan, Seth, Derek. They kind of manage all the technology, make sure that we follow the protocols. We have teams of geotechnical experts who do the review of the wall systems. And we kind of tout it to the wall suppliers as getting 80% to Scott's requirements. So then Scott could come in and download the file and then take a look at it and say, yeah, this meets a lot of our requirements except for these 5 things. Okay. And one of the big things that we did for IDEA is that we now have all 50 states, their gap analysis. So all 50 states are on the website. So a wall supplier and a state DOT can have a conversation about their report, which might get them 80% there, and then their state supplemental requirements that the wall supplier is fully known when he goes through the program. So hopefully there's a good synergy there. And Alan,
thank you.
That's all I got. Thank you.
All right, thanks.
One quick comment. So it's not obvious, but all 3 of the tools combined with GeoSeta that Federal Highways has sent over to Geo-Institute to administer are really data boxes, and they're designed to be integrated data boxes by all accounts. Geotech tools being the sort of base of the whole thing, but being able to incorporate something like IDEA into it, and then DIGGS being sort of the overarching communicator of data in general. We're nowhere near where it would fit with what we're doing here with DIGGS, but you could envision in a few years the idea that that repository starts to become, with the help of GeoSeta, just an enormous data set that allows us to look at a lot of different things in a lot of different ways and not just subsurface investigation data.
Yep.
Good. We'll collect the data and figure out what we do with it later.
I'll have to figure out what you're going to do with it later. It's going to tell you what to do with it.
Right. It will tell you what to do.
Somebody is going to come up with a new idea. All right. I think Scott and Ross did a good job of a couple data conversion presentations, so we've morphed a few of these things together. Nick, you want to talk about the toolbox you're working on developing for the NHI effort?
Yes. So as part of there's, I'm not sure how many people are familiar, there's an FHWA funded project where GI is developing an NHI course on data management. Part of this course, and actually in order to make this a little bit more effective, we decided to produce some demo videos that will help the beginners or those who may know a little bit about DIGGS get some more hands-on experience or a little bit more of an overview of how DIGGS looks like instead of just going over slides. So this content is organized, the demos I should say, they're organized in 3 different modules. Module 1 is about using DIGGS to add structure to data. Since we have this well-documented DIGGS schema, this can be used to add structure to unstructured data or semi-structured data so that it gets to a form that anyone can use, really. So with regards to that, in order to demonstrate that, I should say, we decided to build some very basic programs that perform some tasks, such as for example, creating a DIGGS file using structured forms. So if someone wanted to quickly create a DIGGS file with some basic values, maybe they're not that familiar with the structure yet, but they still want to type in some project information, some SPT data manually, that is, then this can be done through structured forms. Using spreadsheets to get data into DIGGS. I know there's several tools out there, such as the feedback tool or the tools that Data Forensics puts out. But again, as a demonstration, how is it done when someone wants to get going without using any of these tools? Or maybe they want to get a head start and build their own tools, because that's a great thing with DIGGS. Some small programs, a small demonstration there on how to get data from GINT to DIGGS, which again, there are some options out there, but through the demo, what we do is we present these programs, and we also talk about the value of templates and mapping, which is very important in any import-export data process. Module 2 builds on Module 1, meaning that we assume now that we have data in DIGGS, so what can we do with that? Which is a question that comes, I've heard a few times actually. Some DOTs have invested a lot in building those workflows and putting DIGGS files out there, so now what? Well, we go through a few steps there showing how we can now go from DIGGS to tabular data. So someone may go in and select some of the values and get them out as spreadsheets. Maybe someone can use DIGGS to import soil information in other software, such as APILE. So this is an easy one to demonstrate how we can grab some values from DIGGS and create an APILE input file where we don't need to go in there and type in the soil information. There's a discussion about relational databases. So far, it's mostly a discussion on a project by project basis, meaning we have some data for this project, the other project. But how can we get data from DIGGS to relational databases? And that's useful for organizations that have lots of data. OpenGround is a relational database, but there could be other options as well. Maybe some organizations decide to build their own relational databases. This being primarily a course and not a way to promote commercial software out there, the idea is to offer an understanding of what is a hierarchical data structure versus relational data model or data structure, and perhaps some of the confusion around the fact that maybe some folks think that DIGGS is a database. It's a common misconception. Demonstrating this through a few programs can help as well. And then the third module also assumes that we have data in DIGGS. And in that case, though, we want to demonstrate what we can do with data in a DIGGS format, not just getting it in and out, meaning how can we use a small program to produce a summary of the data that we have in a DIGGS file, meaning how can we quickly inspect the data in a DIGGS file that's not just XML code? How can we get some basic plots, stick plots, by using a very small rudimentary program that does that? CPT plots, or maybe a basic boring location plan based on the geospatial information that we have in a DIGGS file. How can we use a very small program that does this? So these collections of algorithms, of small programs that eventually and hopefully will be hosted on GitHub is something that may be packaged as a toolbox. So for a lot of folks, though, that don't want to get into that, there's also a web page, meaning that very similar to what Shin is doing with PyDIGGS, Python code is very modular. It's extensible, but not everybody wants to work with Python or knows how to do that. So one of the advantages of modular code is that we can add another module, let's say, to it, not exactly that, but let's use this abstraction to build essentially a very basic graphical user interface. It still uses the small programs and the code that anyone can just use and extend however they want. But for those who don't want to do that, they just get a page with buttons and forms that helps them navigate that. So again, hopefully that's going to be on, it's not all Python-based because of limitations with internet connection and the ability for this not to be something that just runs on the web, mostly JavaScript-based, so that it runs locally as well.
Good. All right.
Yeah, there's going to be more on that.
Good. So I think that's a great starting point for the next conversation too, but it's nice to hear that we're going to be sharing those components with the community to try to keep building on that as well as be a teaching tool. Our next topic was really about data management and agencies and how this course or other things can help agencies move forward with their data management needs. And you want to open that up a little bit?
So, I mean, I'm having a very difficult time over the last couple of years articulating what FHWA is doing against what the Geo-Institute is doing. But Federal Highways is not necessarily in the DIGGS business. We are in the data management business and data as an asset, as a business model. And so the work that we are trying to develop right now for implementation of data management frameworks really looks at DIGGS as a tool in that process, but really sort of helping states understand a framework for. So the point I've been trying to get across in this development, and I will caution states that are listening, we have run into a couple of roadblocks here and a couple of hurdles that we're trying to get over. We're not as close with this product as I'd like to be because we are still struggling with the broader concept of what data management means, from the focus of data gathering at the project level, why you're actually collecting data at all, to how you will actually manage data in its aggregate long after you collect the data and you've had a specific use for it. And we haven't been able to get to that portion of the conversation yet. So I'm excited. The work that Nick is doing is really, really good, and it's a very, very small piece of what we're trying to broadly do.
So I had the opportunity to be at the workshop. Chris was at the workshop there yesterday on the sort of the cradle to grave or life cycle of what's it called? There it is. Thank you very much.
I was there all day, man.
Leveraging transportation project data throughout the asset lifecycle. And just one observation from that group is, they're looking at the BIM model and sort of how that integrates, on BIM data and what they need from that data. What was obvious to me was that there is absolutely a need for this kind of educational element among the decision makers to understand what this does within, and how that actually is going to transform the workflow efficiencies. And that was not being communicated. The workflow efficiencies weren't necessarily being communicated. But the workflow, they were understanding there is a workflow. But there are a lot of gaps and things that need to be filled in. And I think this discussion is going to help. I think there might need to be some reaching out to other end users of within the processes to understand this, because that is one of our target audiences. But it's also going to have to be the people who know how to integrate this, the doers in the DOT. So a number of levels I think we still need to reach.
For those of us that were in the instrumentation committee meeting just before this, It's an esoteric discussion going on right now. It is a difficult discussion because we are converging on some definitions of things that we thought we knew that we really don't quite understand. So we got a lot of work to do.
Well, I have to say, we are in an excellent position on going from the ground up, right? Versus where they're trying to solve the problems. And I think if we go to them and say, a huge part of that was open source code.
Yes.
So, we've got that here. And so I think going in with that conversation, they were very receptive. And the gentleman from Iowa DOT, who is the director of that type of stuff, I forgot, and they're doing that. Kennerly. Yeah, Kennerly. When we were in a one-on-one discussion with DIGGS, he was like, "What is this called again?" And I told him, they said, "Well, I need to have some conversations."
Yeah, and I think you made an important point here. DIGGS is much further along than we are, and I think it's an important thing for us to understand.
Yeah, you're right.
So how does that all tie in with the IFC, which is supposedly adopted for BIM models? That's pretty far along as well, isn't it?
Actually, they're working backwards.
The development of technology is always going to be well ahead of what you're going to do with the technology, right?
So the application side.
So, I mean, I could look at a state like Ohio, which is very, very far along in applying the technology. But if we asked Chris a bunch of really hard questions about data management as an asset management concept, he's much further behind there.
I was actually going to ask Chris exactly that. What have you learned from going through all the DIGGS efforts over the last few years about your data management process?
Just like Silas described, I mean, the doers participating in keeping up with what you're capable of doing. I mean, it's not just the state, it's the consultants. And so we're only as capable as our least capable consultant when it comes to using the data, the interchange, the sharing, trusting it. And so that I don't know how long that is. I mean, I sure hope before I retire that this happens. I mean, people are literally going to our TIM site, our GIS-based data, which I go out there and I find boring logs and I go, oh crap, this is a DIGGS file and not a PDF. And I'm like, I don't have Gint.
Now you do. Now you got the PDF viewer for free.
Yeah, I know. That's why I was so excited to see your
excellent.
Maybe birthday with rock science. But anyway, so it should all be a DIGGS file. You pull it down and you use it. And they recognize that in their proposal for their next project, and it's just all seamless and wonderful. And
how about in your internal processes? Now that you're able to get the stuff digitally, are you doing internal processes?
We tried to do some Python scripts to incorporate it into some software analysis, and that had some interns working on that, and our asset management group helping us with that a little bit. But we kind of ran into resource issues and. We haven't really made a lot of progress there.
Yeah. But I mean, if I'm hearing his words correctly and I'm listening right, he's still in the infancy of just trying to get data to a project delivery stage, not to an asset stage.
But I know that it would make a whole lot more progress if, for example, all of our lab equipment and our field instrumentation and all of that stuff was able to consume DIGGS files and then interoperably generate and consume. Because if it was built into OpenGround and GeoStudio, I said, my gosh, if we could use our tablet behind the rig to generate log data and literally never touch it again until it's into our slopability analysis model, it was exactly what was generated. But I need all of the vendors from point A to point Z to be able to do that, and we're getting there. I mean, we're hoping by the end of this fiscal year to have conversion over to open ground that's able to go round trip with a DIGGS file. But still, we haven't put it into something else yet. It's just that viewing at this point.
Actually, I had a conversation with Jim Grigg with ConeTech about exactly that. We'd like to be able to send you the cone locations and the background data so you don't have to re-enter that stuff as you're creating your cone file, and then just send it back to us in DIGGS. There's no reason for us to re-enter that stuff even on the front end of a boring multiple times. So he's like,
hallelujah. Hallelujah.
Exactly.
Jim, you on the call today? Have you finished that yet? All right. Gavin, do you have any thoughts, or?
I like the talk. I went to that talk yesterday with Ben was talking about it. It was interesting to see how the geotechnical elements are going to be tied into this, for the whole digital twin, and the augmented reality. Look, this is all part of that data management and knowing what you have. Maybe you shouldn't put something in, and then translating it over to the non-geotechnical subboard. That's here's the data and using it.
We're getting their non-geotechnical data for geotechnical use.
Anybody online from any of the agencies that have thoughts on data management or want to share a story about what you're doing to help improve or change your data management processes? I might be surprised.
No, I won't be surprised.
Okay, we get Roger. You're not from an agency, but we'll listen to you anyway.
I'm working with many of them,
no
but
because he's constantly trying to solve these problems.
Yeah, I work with many agencies. I can represent several here.
Exactly.
One of the things I wanted to point out, and it's really exciting to see how far DIGGS has come, and all the new cool stuff. I mean, we could only dream about this 3 or 4 years ago at TRB when I was last allowed to fly. So it's fantastic to see. I would put one word of caution in here, in that we have to be very careful that we seize this opportunity and move forward, not seize this opportunity and show how we can move backwards. And what I mean by that is that we have to be careful that we don't promote DIGGS as you used to get PDF files, but now you get a data file that you can turn into exactly the same PDF file and end up with that PDF file that you had before. Because what we should be saying is that with DIGGS, you no longer need borehole logs. And if you see that idea with people, then they start to see a wider picture of what DIGGS is. I mean, one year at Geo-Congress, I accidentally started a ban the borehole log campaign during one of the GBA presentations, and I've been wondering about bringing it back. And that we now maybe are at a point where we can ban the borehole log and be doing data and lose this obsession with a PDF file piece of paper. And that opens up all sorts of discussions.
The way that I try to view it is the PDF should just be viewed as a way to view the data. It should not be the product. So
I think Jen and Jesse had some great examples of avoiding the whole borehole log concept.
Yeah, I agree with what Ron was saying. That's what I've been trying to preach, is that the deliverable is no longer a sheet of paper.
Exactly. God, yes.
And that's real difficult for us because, internally, all this stuff is chained together in terms of the data management stuff and how far it goes within the organization. But our problem, as soon as I started talking about, well, look, we're gonna start treating the geotech guys are going to use the data. We're going to prepare a data report for the contractor, and this concept of the log is for obviously I'm going to look at it one time to get familiar with the project and then use the data however I want to use it. And the bridge design folks didn't like that because they said, well, now what are we going to do when we pull as-built from a project 20 years old and we don't have borings? And I'm like, that's the whole of this document retention system that we have. There's ways to retain all this. So there's been obstacles for us from the institutional inertia that don't understand the concept of the data is the deliverable.
Yeah.
We can make things available to contractors, bridge designers, whatever, however they need it. But it's interesting, where Ohio is relative to us, because, you said you basically stalled out having to get interns to write tools and things like that. From my perspective, the way that the kind of stick that or carrot or however you want to look at it that I have with my employees to treat the data as an asset is the first thing I did as soon as we started kind of gathering all this stuff in one place was I jumped in immediately and started developing tools that they could use during design. Yeah. So it's not, this is where we're going to stash this project when it's old. It's what are we going to do with it now that we can save time with. Going back to Scott's, let someone else put it in for you and only do it once. I got sick and tired of going around watching engineers hold boring logs and do this all day. So a lot of the stuff that Shinping and I worked on, I've got some poor man's alternatives to that I've kind of done internally that my guys can use. It's not this kind of beautiful web-based thing that's to me, that's the big picture. But kind of what we're doing internally is I've got tools for my guys to generate a site plan with, once you put your data into the system once, you can generate a site plan. You can generate all the statistics. You can generate all these plots. And that's now. That's before you design the project. So the idea for me to have that stick or carrot or somewhere in between is to give my guys tools where they want to go put the data into the system. They want to treat it like an asset. They want to make sure they get the digital data from the consultant. And that's helping us kind of steer it. But, I think to Silas' point, the objective of DIGGS is a lot more defined than the objective of data management. That's why we're not as far along with it.
Well, you said that that's the now, and eventually that data set that you compiled over the now becomes a huge resource.
Well, then it becomes a resource for the machine learning guys.
Right. And that's what's so incredible is just from the 100,000 logs we have, we can very predictably say what you are likely to have. And so this whole concept of I just go start a project blind and just drill my standard SPT on the corners of the structure, that's not the right approach. You should be seeing where is the nearby drilling history, and what's the system think that I would have.
So my biggest problem with all of this is that, and I get it, and it is good that the DIGGS group is very narrowly focused on advances that are not only achievable but tangible. I can visualize a boring log, and I've now heard the word boring log 56 times in this meeting so far, when in fact, the messaging on DIGGS itself, if you're talking about how to not go backwards, as Roger said, is to think about data as Jesse said, as the deliverable, not boring log data, data.
Right.
And it shouldn't be bound by the term geotechnical or verifiable or whatever the case is. Data, just get it all. And DIGGS is there to help us find solutions. The narrow solution we're talking about right now is visualizing a boring log, but the solution may be workflow generated. The solution may be bigger, more complex problem solving, how we deal with corrosion, how we deal with liquefaction triggering. But DIGGS is about aggregation of data for solutions, right? Not just about boring. So I think this is the part of the data management that I'm trying to get us to understand so that we can translate that in the right way to states as we go forward.
So yesterday, and this conversation is really helping me articulate exactly what I was hearing and seeing yesterday. But one of the issues was deliverable as a model, not as the data, right? And so that's their sort of focus. And when I went to David Dunfer and I said, trying to describe this, he was saying, you're talking about boring logs, right? And it's like, no, I'm talking about the data right? And so this, how it integrates into how collectively DOTs need to be thinking about their solutions. And there was some discussion about research needs on, and I was talking about data and reliability of that data versus the model itself. But we need to have a conversation with those folks.
Sure. But this, I mean, we got off of his agenda a little bit, but this really does revolve back to one of the agenda topics, which is how do you message what we're doing in DIGGS to the various committee meetings around this building? And really the messaging is that they're all trying to find solutions through research needs, right? And the solutions are all going to be data generated.
The nice thing that we have to our advantage is that some of the activities of people thinking of data are happening and have been happening. I think we are well beyond, in some areas, not everywhere, but a DOT being given by the consultant a stack of paper logs with coffee stains. Many DOTs have their deliverable now saying, give us the GINT file. I know I said boring logs with purpose, right? With the idea that that's one thing that has been transmitted. But let's look at some of the other things that we have that previously were transmitted similarly. A perfect example is data from performance monitoring and instrumentation. There was a day when spreadsheets were emailed, or when the same stacks of paper, not boring logs, but data from inclinometers and other things were provided by paper. That day, for most people, is long gone. There are now real-time websites where the data is taken by the sensor, beamed into space, comes back down, you log in, it's there.
I just got a report with a whole bunch of
I don't think it's long gone.
It's not long gone.
It's that one.
I live in a dream world. I'm saying it has the potential to be Didn't that happen?
I'm going to suggest that we pause this conversation for a second. We'll come back to it after the break when we do talk about research needs and messaging and everything. But before I let you go for break, I wanted to take 20 minutes or so or whatever and talk about getting 2.6 released and some of the issues, topics that we need to get through. So I'm not letting you out of this room until we at least get through this thing, and then we can do a break. This way you'll stay focused. All right, Dan, you had some questions about, questions to finalize the release of 2.6.
Yeah. Oops. And are we going to break now? No. So there are, these are a number of the issues that are on GitHub. Some of these are kind of nuts and bolts issues, and probably we don't need to be spending a lot of time at this meeting to talk about. But the ones that I think are important, and that are important, I think, for really for full interoperability are these issues like number 33, some of these ones that have to do with code list standardization, and there's a number of different code lists. Let me share my screen for a second. I'll show you kind of the ones that I think are.
I thought you had some basic questions about 2.6 itself, as far as.
Well, yeah, I mean, so part of it is getting, so part of it's getting this taken care of, and then some of the other issues have to do with how we want to handle some of the more development level stuff, like the grouting and geophysics, because those really haven't been exercised yet. And I have some ideas. And let me pull up my slide deck, and I'll show you.
Right.
What I should do. Yeah. Yeah, that's it. Okay, so let's go back to the slide before this.
Please.
Okay. So let's see where. Okay, now we got it. Okay. So one of the things that I think is important, this is one of the, several of the items that Scott had brought up, was questions about how can we be sure that, when somebody defines, the role for somebody, like we've got a driller or something like that, that we know it's the driller as opposed to something else. And all of these, many of these properties are of a type that are called code type, which means that they're really intended to come from some control list of terms. And there should be a pointer to a dictionary that defines them. And we do have a property dictionary for our test results, but we don't have dictionaries for a lot of the code lists, some of which are potentially more important than others. And so the ones that have sort of popped up in the context of some of the discussions are the lists that are here. So things like the role, the lithology codes, legend codes for graphics display, codes for borehole purposes, and equipment classes, these sorts of things that are on this list. And what I would like to suggest maybe is that we get some type of a subcommittee form to have these discussions to get this moving, because we've been talking about this for a while, but it's sort of stuff that gets left on GitHub, and a lot of this stuff is sort of out of my level of expertise. It's not something that I can certainly code these dictionaries up, but we need to get these terms, and we need to get some agreement on what we want to be doing. And so I think that this is not something that's dependent on the 2.6 release, but I think it's important for the ability of some of these software companies to operate.
We'll come back to this in a second, because I was going to have Nick show us the issues on GitHub and show everybody how to get logged in and
Sounds good.
Actually contribute to this.
Yeah, sounds good. The other one here is just a very technical one. Is specific energy in terms of what you're referring to, because there's different terms, either mechanical specific energy or drilling specific energy, or both. This is something that came out of one of the AGS codes for drilling advancement, and there's no good definition for it there. So I'd like to we need to get some clarity on this.
That'll come out of MWD, right?
Well, it's going to be important for MWD, yes. That's one of the things that comes out of MWD. Yeah.
Yep.
So that's something that we could carry on with that. The other thing with respect to release considerations, I had talked before at some of our committee meetings about reorganizing the schema file so that they can be chunked out in smaller pieces and then profiled with a single file that then bundles pieces together in sort of small chunks. And I think there's some advantage to this. Whether we want to do this now or not is a different question. But the idea is that a lot of DIGGS is pretty large. It's getting bigger and bigger with all of these extensions. And for a lot of use cases, a lot of the schema isn't necessary. So this is a way to be able to kind of pare down and say, look, we can develop some core profiles. An idea being something very basic. Borehole soundings, limited tests and samples, for example. You could specify the in the choke.
That's on our 2022 to-do list. And I know Ross started the Geotech one at one time, so we got to come back to that as well.
I think I'm comfortable to say that I've got a rough version of it, because.
Okay, so this is something we can do as part of this release. It's just a matter of reorganizing the schema files and the objects in the chunks. It doesn't change anything with respect to how the instances look or anything like that. But this is a pretty good. I think it's an important thing to do at some point. And if we've got some ideas on that people want to feed to me, then this will be really good, and I can pull that together. The other thing is that I've already started.
Yeah, Dan, Nick had a question.
So if things are reorganized, then 2.6 is no longer compatible with older versions, right?
No, it's just a matter of instead of having one, for example, right now we have most of the core schema objects are in two big schema files, and two different namespaces. You can break those up into individual files that are smaller within the same namespaces, and then have another file that just puts together the pieces that you want to for a particular application. Doesn't change the instances, doesn't change how the instances look. It's just a matter. It's just basically having portions of the schema available for particular purposes. So you'd have a complete that would have everything. You could also have a profile that pairs down you can't pare down an object. The objects have to stay whole, but you can decide what objects you're going to work with and which objects you're not in the profiles.
Okay.
So
sounds like a subcommittee project there.
Yeah. So that's a subcommittee project to get those ideas, and we can implement that as part of it. The other one that I just wanted to get some feedback on this is I have a stub object in 2.6 there that will allow us to write out component objects. These are composition objects, ones that are never going to be referenced right now because of the GML requirements and the fact that we've profiled or we've inherited every single object in DIGGS from GML objects. Not all of them need to be. They have to carry a mandatory ID, which means that to generate DIGGS files, a lot of times you have to make up identifiers for things that don't make a whole lot of sense. And I've figured out a way, and I've talked with the OGC folks to make sure this works, of making the GML ID optional for those objects. So we just need to switch those base types, and then the ID isn't required for generation. The IDs that are there still fine. There's no problem with that. I just wanted to get a sense as to whether you guys think from the DIGGS generation standpoint, going from a data source into DIGGS files, whether this would be a worthwhile thing that would save you a lot of headache in programming.
Yeah.
I'm just wondering whether you think that's true.
Absolutely.
Yeah.
So you make it optional for individual objects one by one? Or?
Yes, please.
Well, individual,
you know,
so for example,
so much noise.
Yeah. So for example, let's say you have a borehole object, and it has you've got casing information for the borehole. Every single one of the casing objects has to have its own identifier. But those casing objects are never going to be referenced anywhere else. They're always going to be contained in the open master borehole.
Yeah, but my question is the GML ID blanketly made optional or only made optional for certain objects?
It's only made optional for the objects that don't require IDs. Yeah.
Okay.
Yeah, the major objects are still going to require IDs.
Do I have a problem with that?
Two of us are very strongly.
So very strongly. The guy that understands what it might mean.
Dropping off.
You okay with that? Seems like we got heads nodding. Anybody not okay with that?
Nodding? Okay, good. I can't see your heads, but I'll trust.
I'm not sensing any no's.
I have a broader unrelated question that'll eat up too much time, so we'll take it up over beer later.
All right. Okay, so that one I think you're good to make some optional.
Yeah, and then the other thing, I haven't made any changes in 2.6 about this. And I brought this up before, got poo-pooed a little bit by Scott. And maybe this isn't something for 2.6, but the next versions is right now we have two namespaces in DIGGS. One is for everything. One namespace is exclusively for test procedures, and the other namespace is for everything else. Basically, the DIGGS main namespace. I'm starting to have some issues where when we're in the grouting profile, profile, some of the test procedures that you would use for grouting are also geotechnical procedures. There's material tests that are just done for grouts. I don't know what the heck namespace I'm supposed to put these things in. And I'm thinking that if we were to go to profiling, one of the reasons for having the namespace is to say, well, I support this particular subset of DIGGS, and you have that subset in that namespace. But if we can do the profiling by reorganizing the schema pieces, there's really no need for a secondary namespace. And so I would like to suggest that we consider deprecating the DIGGS geo namespace. We'll still leave those objects there, so existing schema or existing instances will work, but that everything collapses into the same main namespace, and then we can use profiling to separate the types of procedures that are useful for certain things, and procedures that are used in a number of different domains. Test procedures can be lumped together in another schema file, and we can set that up with profile.
Can we delegate that to the subcommittee that's going to look at profiling and let that be kind of tied together?
Yes.
Decide whether that's appropriate or not.
Yes. But those are the primary issues. I think if we do profiling, we can manage the development pieces well enough. We can release 2.6 and say, hey, this particular profile, geophysics, for example, is still in development stage, which means expected things might change and break.
Okay, so if we want 2.6 release, we got to get this subcommittee moving on profiling.
Yes.
At present, we're giving an object ID to every single thing that anybody defines, right?
Yeah.
Whether it overlaps or looks the same. So if Ohio calls a 4-inch PVC tube something and Louisiana calls it something else, they get 2 object IDs.
Well, that's useless.
Right, and they're unique to that file.
Yeah, they change on every file.
Right,
So
every file.
even if Ohio called it 4-inch PVC on project A and project B, they would have 2 different GML IDs, and
despite the fact that they're the same thing.
Right.
Yes.
Right.
They're completely useless.
Just inside the file.
That's why they're not helpful, because you can't view a file over here and say, oh, well, this file joining it, the IDs are just
It's just overhead.
arbitrary.
That's why we don't need them.
Okay.
You can go to break. I'm going to keep talking to him.
I'm not going to break yet. That's what I'm saying. Shut up for a minute so I can finish it. Okay. All right. So we had all these code list items, and I guess what I want to do at this point is not go through the code list, but I want to make it clear to everybody, sign into the DIGGS GitHub site, especially you agency folks here that actually have a dog in this fight, because we need you to start contributing to these conversations. So we can get a task force together to start focusing on individual code lists, but it's really going to affect you. You know, if there's something not in this list that you need, you need to help us. So if you sign in, and Nick's going to show us how it's all done here soon, real quickly, you'll get notices when these issues arise, and you can just throw in your 2 cents real quickly. Yeah, I like this. I don't like it. Add these other things to it, just to make sure that we create code lists that are functional for you. You want to use this? Or you want to use yours?
Steal your screen here.
It's fine.
Okay. All right. So there's ways to contribute here that's not necessarily writing code. So anyone in this room can contribute. It can be as simple as replying to emails and saying, hey, yeah, I agree with this, or I don't agree with this, or how about that? So if you want to participate in lovely discussions between currently, primarily Scott, Dan, and Alan.
It's on mine.
Right.
Yeah, we would love to have more people contributing, please.
Yeah, so it could be as simple as getting an email like this and saying, hey, I can reply and add my 2 cents. So this is a discussion going on there with Dan, or here's another one where Scott asks a question or posts a comment there and says, hey, we need this, and then Dan replies. So you can look at this and you can reply and add your own comment. So the way to do this is to just subscribe to the GitHub site. So we have a GitHub organization, which is DIGGSML, pretty easy. So github.com/DIGGSML. And this org unit has different repositories within. In this case, I've pinned the 2 important ones, which they're the ones you're going to see up there at the top. One is the actual DIGG schema, the repository for the schema. The other is a documentation, just the generated documentation. Some people maybe just want to look at the documentation without loading it on Oxygen. So in here, in the DIGG schema, there's an issues tab right there, and that's all the discussion that you saw happening is essentially someone here opening a new issue or replying to an existing issue. You don't always have to be here to do this, to reply. So going back, the only thing you have to do is create a free account on GitHub, and then go on this repository, the DIGG schema, the main one. So essentially github.com/DIGGSML/DIGG schema, and watch this repository. So I'm already doing this. I'm going to show you how it looks like on one that I'm not following. So here's a repository that I'm not following currently. If I wanted to get all of the notifications on this repository, right here it says watch. You can select all activity. And this is going to send you emails on issues and other repository related activities. That's it. So number one, GitHub account. Number two, github.com/DIGGSML/DIGG schema. And step three, watch all activity. This way you're going to get the emails on the issues. And whenever you see, this can keep you up to date also. You can see what kind of work is going on, or you can just chime in. Get the email, reply with thoughts. Now, this is the easiest way. If you want to start your own conversation, up here, big schema, as we were before, issues, tab, and create a new issue. So it could be a new question. So yeah, the issue is a term that was used very early on in version control systems. Now it has evolved to be more than issues. It could just be conversations here. GitHub has added some new tools to start discussions, but let's not complicate things. Let's stick with what we are using now, and it can evolve as needed. Right. So once again, 3 steps: GitHub account, go to the repository, watch with all mentions. That's it.
Awesome. So we want us to move forward with these code lists and everything, which we need to do, as you heard, Dan. You have to help. So sign up, provide your 2 cents. We'd appreciate it. And with that, believe it or not, we're on time, maybe even a few minutes early, and we have a 5-minute break. Unless we want to overrun Silas's 2:50 time, in which case you have a 10-minute break. All right. So Silas mentioned earlier there that we do need to talk a bit about research needs. This is really our opportunity to go to all these other research committees out there and provide some input. And forgive that, that's just kind of a brain dump from conversations, but this is our chance to put feelers out there or ticklers to get people to start thinking about data and data management, and more importantly, maybe how DIGGS ties into all of that so that we can keep advancing the efforts. We've been very successful with DFI and GI in getting support for this growing effort, but TRB should also be part of this, and I think we can plant some seeds over the next day or two here. Silas, Ben, any thoughts or comments about where to start this conversation?
I mean, I threw out my first piece earlier, where I think we have to think more broadly about what DIGGS provides at a meeting of state departments of transportation about research needs. And so, you know, in the instrumentation committee earlier, I was talking about I couldn't even figure out what the research need was, but it was essentially looking at uninstrumented monitoring for, you know, evaluating structures and evaluating state of repair, things like that, and recognizing that it requires a lot of external data. So the premise goes like this: 4 million lane miles. You obviously can't put instrumentation in everything that exists and in ways that you could try and measure or understand performance. And so you've got to find other ways to sort of get into the business of geotechnical aspects of transportation asset management without instrumentation, right? And so how would you do that? Well, we have a bunch of remote sensing options that would allow you to look at deformation, but you have to be able to figure out how to convert that into something that tells you something about materials degradation or structure integrity or whatever the case may be that you're looking at. And we don't really have a way to do that yet, but that's a data problem, right? And so it's really a DIGGS problem. It is our need to figure out a way to identify the types of data that we might want to look to solve that problem, or just look for different ways to aggregate data through a system that's designed to aggregate data to help us out with trying to solve bigger, broader problems like that.
we started up a LiDAR project, right? So we can get this data, but how do you store it without using a giant supercomputer and manage it and interpret it? That's a simple tool or so that's a problem.
Yeah. Yeah. And then the other thing I was thinking about, I talked about it on the call, was just communication structures that once we get outside of geotechnical engineering and we start aggregating data from other sources, they actually talk differently than us. For those of you who sat in on the corrosion of buried structures webinar, it was their first and most important recommendation to us was to get together with all the other disciplines that deal with corrosion and start trying to communicate with one another, because it's impossible. And so we'll have our own internal communication issues, just because as we get to do applications, we call different things different stuff in different applications. Just look at ground improvement as an example. But when we get outside of geotech, it's going to get even worse.
Yeah, and on the bigger picture of, where do we want to take? I mean, obviously there are a lot of use cases for us in the workflow that our data provides. What I was seeing from yesterday's workshop is that those guys, they don't know what problem they're trying to solve yet. So I think it's helpful for essentially what they need to do is disaggregate everything that they think they need because it's very piecemeal at this point on how they're building this BIM model, right? So they don't know what data they need or how that's going to be used. So I think we know that aspect, right? And I think that's something that we can help them solve, because by solving that problem, we're going to have an inroad, or the ultimate game is looking at how we do practice differently. Right now, they were talking about pay items and having a disconnect between the pay item and the model, and there should be no disconnect, right? Because it's all that the data, all those decisions are being made on data differently, but they were sort of having these kind of piecemeal discussions. In fact, the way they were talking about research needs was design, construction, asset management. It needs to be more continuous.
So I just want to caution all of us to stop putting boundaries on the discussions. So you're talking now about workflow and about project delivery, but again, it is data.
Right. Right.
That is a solution.
That's right.
Yeah, okay.
And that's to meet that particular need. You're right. And then, of course, they're talking about asset, life, and right. They are completely focused on solving that problem: project delivery and asset management.
Yeah.
Can I propose something I could see as a proposal? Could be, we now have all of this data from all of these places. I think there is a huge amount of additional value that could be derived. And I think there could be a big research opportunity to say, here's this giant set of data, find interesting things.
Do you guys access your state MBI yet? Your bridge inventory data?
Well, yeah, we
Do you feed it through DIGGS and into anything you're doing right now in geotechnical data management? You guys? Or pavement data, because you have big pavement data repositories in the states also?
So coming from
but it's publicly accessible. Like, I can go get your data right now.
Some DOTs do, some don't.
It's not an automated process. That system can't talk to something else that they wouldn't do it manually.
Yeah, and that's where you need DIGGS.
We're talking about research needs, right?
Because what we work on with Louisiana, where they have a pavement management system and they need some of the shallow borehole data and lab testing data that they do.
Well, they may need all of
to a
that
different
data.
System.
I mean, arguably, you'd want all of the data.
Absolutely.
Right.
Absolutely. But what I'm saying is the pavement management system wants a subset of it.
Right.
So, I mean,
So
we have these.
if that system could import DIGGS data or export DIGGS data, that'd be awesome.
And
Ashton, same thing.
We have these enormous data sets in all 52 departments of transportation. We have an enormous data set at federal highways. They're obviously all in a data form that can be easily translated. Otherwise, we couldn't translate it, right? I mean, there probably is a research need to figure out how to start now integrating what we're doing in DIGGS with external data that's available.
Yeah. Just to say, as a previous Maryland state employee, we did tons of coring, tons of PR. As part of a research project that I had, is we pulled out all of that data, we trained off of it, and found that we could predict pavement cores at like a 95% accuracy.
I want writability numbers. I want just about everything.
Yes,
yeah.
and you can start to do that.
Yeah, because I mean, you can start to section off pavement and start looking at
completely,
you know, what the life cycle data they're collecting against what we know about the geology in an area, and start to, you know,
but those are the kind of research projects that we need to have. Is okay, take all of this data. You could, from DIGGS, from pavements, from all of these places, and find out how they trend, and find out what you figure out. And I think
if it's
more data,
I mean, environment collects a ton of data. We could definitely,
and most of them don't
collect so much.
Project it's been taken for, which used to drive me crazy.
But I mean, we collect so much climate data that it's kind of scary. And again, just seasonal changes in, you know, how much rain we're getting in certain areas and things like that. Is probably data that's useful to us.
Completely. So, that's the big opportunity I see is for Geo-Institute. I have tons of data. I don't have the resources to go, oh, let's go find out how this core relates to blah, 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 blah. Or to, like, that's where there's this huge opportunity as to how do these sets join up.
If I'm the National Weather Service and I've been capturing this climate data, I have my own database. People who provide data to me have a standard system that they provide data. The GitHubs have been the ones who've been in the back seat because we never had a standard way of reporting the data. They have a standard. So what's the motivation for them to transfer that using this esoteric language, i.e. DIGGS?
I don't think it's not their responsibility. No. It's our responsibility to go get it because it's publicly available.
So, but all it would need to get from them is to say, tell me, because it's already in the database.
Right. I understand. We're just trying to translate it for our own use.
So what fields in their database do you need access to that you can bring over? You don't need DIGGS, or you need DIGGS for those specific files.
If I understand correctly, DIGGS is a data aggregator. And so I want to pass as much data through it as possible in order to get it all into the same place so that I can start looking to find solutions, not just visualize it for any purpose, right? I want to be able to do just about anything with the data once I have it. But you need a way to transfer it from that database to where all of my other data is being aggregated, right?
Right, but that's two databases and do an analysis across the.
I was about to say, I wouldn't touch anything.
Yeah, you don't want to. You just want to
keep it as they have it, and then you bring it across, and then you do the.
We're currently not changing anything about Ohio's data. We're just getting it into a form so that DIGGS can read it.
Right.
Okay, but you're not like translating.
No, we're not changing anybody's data. That's never been the case.
The way I was hearing, the response is you pull the data from their API in the format that they have, and then you figure out how to take your DIGGS data and then join it. Like you are trying to transfer it inside of DIGGS, or say that they have to store the things in DIGGS.
So my point here, I guess, goes like this. I don't know what the end product looks like yet. I'm not talking about GeoCeta trying to visualize what's going on at Louisiana's pavement offices. I'm not interested in that. What I'm interested in is getting the data and then figuring out how we would use it on the back end once you got it out the other side. So I mean, like I in my simple mind and way of thinking, I think about this in the Google model. When Google first starts, they had no idea that 25 years later, I would open up Google Maps and I'd put up a list of restaurants, and next to the list of restaurants, for me alone, Google would literally list every restaurant I've been to as similar to some restaurant I'm looking at in a new city. That's about them aggregating as much data as they can possibly aggregate, and then figuring out how to make that data useful in different applications and in different ways. And I don't know why this isn't any different.
It isn't.
Yeah.
Well, is every one of those data aggregations a custom effort? Do we have to have custom scripts to go do it state by
I
state?
think that's the value of the the research project, they don't have to, as assuming that the geotech stuff is provided in DIGGS, but to join up to additional sets, you are going to have to have some kind of filtration, conversion, blah, 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 so that you can start to do the data science. But that's where the value of having it be a research project to see what kind of value can we find. And
yeah, it seems like every research project has to be an example of what we're capable of doing, and as something to show generators of data, i.e. the states, what they are capable of doing.
My least favorite thing about practically applied research is that it is nominal advances based on what you've already known.
Build up on what I said about uninstrumented structures and also value of data, although you don't know what you're going to do with it. For example, it just happened to me, your example. Okay, we know the geographic locations of the uninstrumented located structures. That's one set of data. We know the extreme events or any event, weather events from that data. We can bring it in, and we can bring in USGS earthquake data. We can bring in other data, everything. So we have even observations. Like, how do you know that structure actually survived that without shifting? That's another layer of data. Maybe later we look at all these information together and say, here it is. Now we can use this data because we have access to them and we collected them, and we can come up with a predictive model. Train the AI to basically tell me likelihood of such and such uninstrumented structure failing under such and such extreme event.
Well, we need 5-year-olds in the room, like literal 5-year-olds in the room, though, that don't go into these problems with an expected answer. It's just.
Well, that's my question. Are you proposing to go into with some hypothesis first, or are you going in agnostic of what the end result?
I think the hypothesis is the more data I have, the more opportunity I have to solve a problem.
But the problems you have to define ahead of time.
Well, not necessarily.
No. So some of the neat processes with machine learning is, and I've had this happen many times, I say, oh, well, it would probably be helpful for me to include the geologic formation for the training. And I try it, and it turns out it doesn't help at all. It creates a ton of confusion. So there's all kinds of opportunities to be similar to a 5-year old and just
so you can't think about this like you're going into master's research or PhD research where you have a hypothesis and you generate a data set, you come to some original conclusion that fits your hypothesis. It's not really the way to think about this. It's got to be a much broader concept because you don't really know what you're going to do with the data later. You just know you want it.
So can you sell that? I mean, I understand the value of where you're trying to go, but since research typically does have that.
Stop saying, don't use the word researcher. This isn't.
Okay, so you're not talking about research needs here? Or what?
No, research is a solution.
So what, I guess my point is that who's doing this? Is it transportation?
Doesn't matter.
So we're not trying to solve anything.
DIGGS isn't owned by transportation. It's owned by the Geo-Institute.
But what I'm trying to figure out the end game here of this conversation.
Stop trying to figure out the end game.
But we are coming to the end really soon.
I disagree. I think the research project I started at Maryland had huge value in that it's what started GeoSeta, and like the value that this to date has gotten out of it is just crazy, because now they're starting to use all of their pavement data, they're training off of it, seeing like when a new request comes in, there's a prediction that happens, blah, 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 blah. It's huge. And why is that not a research to go beyond just one state and say, hey, there's all of this data that we are trying to standardize. How do we go beyond that and create valuable tools that the states can all take advantage?
All right. Okay. So my research need in all of that was I thought we needed to help the states find a better way to access available data in their states. The rest of this is just a concept.
So this started out as what message can we take to committees that we're going to be in over the next day and a half? Are these some points that came out of this conversation that can be mentioned at committees, and do they capture the gist of what we were sharing here?
I would be more blunt and say use machine learning to derive valuable models from our data. And like,
if we want other people's data, wouldn't other people want our data?
And they should have it.
Eventually.
That's your
Eventually.
That's your carrot stick to say, if you want our data, help us implement the DIGGS.
Exactly. Yes, you are speaking the truth. You have to say dates. This is
okay, but I'd go back and say it's Nick's description of it is structured data. That it should be standardized and it should be structured
and interchangeable.
That's a detail though. That's not a message.
No, but that is the message, because a lot of people do not have their data in.
I got it. I got it.
As an owner of a ton of data,
right?
If you come to me and say, "Hey, we want your data," I say, "Oh, what you can do with it? I don't know yet, but give it to me." Well, what format do you need it in? Assuming I got buy off, and you're going to give me a format. How am I going to pay to put it in a format to give it to you to do? We don't know what yet with.
So again, I like I said, I said this at the beginning of this meeting. I have been struggling to try and articulate some of these points for like 2 years. I don't want to ask you for your data. I want publicly available data that I can already go get. I don't want you to do any work. Yes, I don't want you to do any work.
So
how do you make it?
I have to jump through a few hoops.
Right. A lot of it.
And then I have to filter out.
So the research.
Which I don't have.
Right.
So the research for us is, if your data is publicly available, we need to figure out how to get that data into a form that works for us.
And let that be
publicly available.
You have a list of ones that we already know are in that format, and then share that.
Do that too. I don't know. And you tell me.
Or whatever, right?
I'd like to make it publicly available. I need to be told and funded to make it.
Okay, that's fair. That's fair. But there is so much data available even without yours, or without Rhode Island's, or without Geo-Congress. There's still a tremendous amount of data.
But it takes some.
It takes some work.
That's why we're doing research. Well, okay, so
do you want just more of GeoCeta then?
Right.
If you're just looking for data compilation.
Right.
no, I'm not looking for data compilation. Huh?
What system are you drawing a circle around to define what data you want in some system? Is it a wall? Is it a piece of soil? What you have to draw a system. You have to draw a budget around the system to then query what is inside.
Okay, we're going to circle around this conversation for the next 3 days, apparently.
I would love to have your help in trying to help convert all of these DOT's files that come across.
You want me to tell you a little story, because we don't have to reinvent the wheel here. Right?
I'm not asking you to reinvent the wheel. No.
So this has already been figured out by all of these big companies. They're doing all of these things now with machine learning. You brought up Google. The first thing that these companies realize is that they don't know what they don't know. Now, forget about what it is that they don't know in 10 years or what they will know in 10 years. They have no idea.
Exactly.
So they went into data hoard mode, but with two caveats. One, data structure, meaning that we're not just going to throw data, whatever. There should be, it's either you either apply a schema now or you apply a schema later, but there needs to be some structure. And number two,
go ahead.
Number two, always make sure to pause every now and then to see if there's something you're not collecting that's probably going to be required. So it's the equivalent thing of, let's say, a company using Gint for decades and thinking that they have a database, but they didn't store lat long in there or Easting and Nordic. And then 20 years later, they're like, oh crap, I cannot put this on a map.
20 years ago, we weren't storing data at all. I mean, so I'll narrow it this way then, and I'll stop my argument here. If I told you that the only thing I wanted to hoard was boring information, linear exploration test information, you jump at that immediately because you already know what the outcome of that is going to be. And what I'm saying to you is you can't think that narrowly about geotech as a discipline if you're trying to solve bigger problems. Hoard data.
But you got to have the support to be able to hoard it, and you have to have.
I got it.
Do you? Because what you're saying is, I want to go beyond just
you can't solve the problem you don't know about until you've created the problem.
But don't you break down stuff in its component parts to build up?
You got to start somewhere.
All right. I hear you.
I
understand more. All right. I don't know whether we're getting anywhere.
Yeah.
We're not getting anywhere. We're saying the same thing over and over. Yeah. Okay.
All right. Trust me, I'm more articulate over bourbon, so.
For the first 3 or 4, and then. All right, so I will send an email out with these notes on it. So if anybody's in a committee meeting and wants to be reminded of this conversation, there are some points that you can twist and use in any way you want, but feel free to throw these out. And everybody's looking for research needs, and this is just a step towards it. Right. So let's talk about visibility enhancements. We have about 25 minutes left to go. Right now, we have 2 main portals of information, the DIGGS GI site and the GitHub site that we've been talking about quite a bit. GitHub's a little more live than the DIGGS site, although Peter's been doing a good job of adding new stuff to it, but it's probably 5 years old since we renovated this thing and might need some livening. So I want to turn this over to Derek a little bit and let him share some thoughts and stimulate this next conversation, which could be almost as exciting as this last.
Probably. All right, so the formalities are, I'm talking about delivery of geotechnical data future. The next slide is our disclaimer. You're not obligated to listen to me at all. Okay, so Ben had been reporting on and talking about the meeting that we were at yesterday about leveraging transportation project data throughout the entire life cycle. I just want to mention the co-sponsored committees. because this gets a little bit back to research needs. So geospatial data acquisition technologies, construction management, transportation asset management, and geographic information science, as well as utilities. So there are a number of groups that are interested in sharing their data of different types and in different formats. So DIGGS is getting noticed internationally now through our cooperation with the Open Geospatial Consortium, as well as our presence with some other international groups. So we've been, Dan Ponte's been on the calls where we've been talking about people have been working with IFC Tunnel, where a lot of the work in the IFC code is currently going on. And the reason I'm mentioning IFC is because AASHTO has 2 pooled fund studies, that one for bridges and structures and one for other general infrastructure. And they have adopted a leadership statement that says we're moving to IFC, these industry foundation classes, to exchange information in the digital space, moving away from paper plans and specifications to the model as the deliverable project to contractors, as well as the model extending on and living on as a digital twin and potentially being used for asset management and value for digital as-builts, and potentially then being used for future projects. PennDOT, Utah, some other states are involved in this. So DIGGS is our geotechnical opportunity to be part of data management, where we sort of imagined it in its beginnings, getting things from the field and from the lab into the office for design, analysis, and what we recommend, but then also getting that into the construction package and then eventually into asset management. So communication of geotechnical data to others. You can imagine also people involved in utilities are interested in this information. And if there are any operations and maintenance issues that come up there too. We've talked a bit about how with standardized formatted data that it becomes much easier to use for AI and machine learning, which rely on large formatted data sets, reliability-based design calibration, integration of these elements into other platforms, and then as part of e-construction and digital delivery. So this is sort of our interoperability kind of little quick cartoon with the idea that between all these different things, DIGGS can be used as the agent to communicate. We don't have to have independent correspondence files, Excel files, people moving columns and around, selecting units of measurement, saying what's in each column. That's all defined. So my on-site tablet can talk to my laboratory management software. That can talk to my data analysis software. That can talk to my BIM or my GIS software, and it can go to external customers, internal customers. The universe awaits for our data. Talked about BIM, the model, the idea is that this contains all the information for the project. So people who have been working in BIM so far have thought about it all as manufactured or constructed products and essentially the Legos that go together on your tabletop. There have not been a lot of thoughts about the natural world interacting with this at all. So when we have things that are different from something I have physically manufactured or constructed and placed in a place, the world is a different place. And yeah, that even is in some of the nomenclature and things that we're talking about. It's like, something changes in time. That's not quite right. Something is not homogeneous and the same throughout in an object. That doesn't seem right either, right? I've manufactured a beam or a product or a can of Coke. They're all supposed to be what they are. So we're integrating some new concepts to some of our peers. Application of BIM for infrastructure projects is growing nationally and internationally. This is especially true, I think, now for larger or complex projects that require three-dimensional design, virtual models. So the more complicated your project, really, the better the information can be leveraged. If you think of expensive, large CMGC and design build projects, that's where having these models can really shine. If you have a lot of elements that are geometrically complicated, that interfere potentially with one another, or even interface with one another. I mentioned the implications for asset management. So 23 states are a member of this AASHTO study. And some of the things that I've been talking about as drivers for getting our geotechnical information into this are things that we talk about generally with geotechnical engineering. Reduced risk, project cost implications, better quality. faster project production, easier administration and fewer change orders, increased efficiency, and improved as-builts for future projects, the basis for operations and maintenance decisions and asset management and future value. So the thought is that we take all our geotechnical information, we provide it to the designer, we're trying to build a product. They then provide this standard deliverable through the AASHTO format that goes to the contractor, fabricator, owner, public stakeholders, and we are part of this larger ecosystem. So with the closing thoughts here, you know, DIGGS is transforming our world right now, and things that we're doing, we're able to see it. And at the end of the year from the Geotech Special Project, hopefully we will be able to say, we can take information from the field, we can take information from laboratory testing, we can begin to visualize that in space, put together boring logs, access it in GeoCeta, access it in rock science analysis programs, send it off to visualization programs or to the contractor, all still in a digital state. And then we have these benefits where we now can interact efficiently with one another, which takes the burden off Georgette. She doesn't need to figure out how to export all the data. She presses the button and says export to DIGGS. And much like George Jetson and his difficult day. So workflow for design, construction, and operations. And that's that. So thank you, Alan.
Absolutely. So what did that all lead up to there?
Fixing Silas's problem over burning.
I don't have a problem. I have a problem.
It's not even a problem.
He's trying to define the problem.
I have to find the problem. I'm trying to define it to a room of engineers, and I know I'm an engineer too.
Well, I think though that this conversation starts more with the messaging. So if you think about, are we sharing the right message with future DIGGS people with the visibility we have right now? Or do we need to be doing something different? You know, we've come a long way in the last couple of years. That's probably, we shouldn't be doing the same thing for the next 5 years that we did for the last 5 years.
No, and I think what you have in this presentation would be a good basis for an overhaul of the website.
Yes.
Because those are all the compelling reasons why.
You're exactly right. One of the things I talked with Christina and Alan about is changing our web presence on the GI site from principally a developer site. I mean, we'll have those links, but when you go to the landing page, it will be an interoperability and data exchange focus.
Yeah.
I think it needs to hit everyone across the head of this is the value, and these are the products and the things that you can do. And then for future research, it needs to be finding more value. So,
seems like we also shared it with our geotechnical colleagues. First, we also need to share it with our structures and bridge people, let them know
Pavement.
this is the tool that's going to help you get that data.
If this was presented yesterday, this would resonate as far as, you know, we need to step back and look at this differently.
Yeah, but I think we're just now getting to the point, philosophically this makes sense. But until somebody can show that if I can give all this geotechnical data for this tunneling project or this massive bridge project to a contractor in a digital file, and then they can do something with it to expedite their bidding and risk management process, it's that use case really that it'd be nice to figure out how to build that out and then
They've
sell
done
it.
that overseas.
Right.
I mean, any number of massive projects in Hong Kong or in Australia or in the UK, and they're doing it.
I've asked Dave Unker if he, you know, has contacts with to get those use cases specifically for the data that, I mean, obviously there were a lot of decisions made along for the Hamburg Bridge. But anyway, yeah, I think we can dig more and find those.
I mean, the research project for Maryland saw that we were saving $1 million per year from having it in a standardized format and where we could see all of the drilling history. Like,
what is the relationship between GAM and DIGGS right now? Is that frontier been?
So the relationships between data management and GAM, right? So data is a geotechnical asset.
But I mean, our example is a boring one and laboratory test data, and that's it. But GAM is it's what everyone else is doing. They're doing asset management. This is my bridge, and here are its components, and here's how it changes over time. So here's my embankment. Here's my rock slope, and how is that being translated into data? Yeah, into this overarching transportation information management system. How does geotechnical asset management in a DIGGS format fit into this overall model?
I don't. At the moment, it doesn't.
Yeah, I mean,
but,
is there a place for that?
Well, it's not that it's off. It's not that it's off the radar. It's that we don't do a very good job of understanding deterioration of assets, right? So. The reason why transportation asset management works is because you're looking at deterioration over time as part of your strategy of managing the asset. We look at things as pass fail, right? Because it's impossible to sort of look at a slope and determine that it is somewhere along a path to failure, right? It's either stable or it's unstable. And so data management as a construct would ultimately be a central piece of geotechnical asset management or geotechnical aspects of transportation asset management, but we aren't there yet.
Does it even need to go through a DIGGS format? I don't know. I mean,
well, I would say that right now with some of the work we're working with OGC and Building Smart IFC is that there is a recognition that a lot of groups have independent data structures and data sets, and they should stay in those data sets. So that's why there's Hydro XML, or that's why there was supposed to be Trans XML or Geo XML. There are a lot of contributing pieces into the puzzle, and the idea of digital twins in the BIM IFC is that every contributing resource and discipline does what DIGGS is doing for geotech. They agree on their own culture, schema, systems, everything else, and say, we are using our data in this way for us. NOAA did it for their climate data. NASA does it for whatever data they have, and so forth. And digital twins and BIM IFC are the data aggregator. So where we talked before about the idea of how can we get other people's data and how can we do things with it, the idea would be that if I create my digital twin for a project, I pull in the climate data that I need for sustainability and resilience. I pull in the DIGGS data for geotechnical. I pull in the subsurface utility data for the SUE and the rest of that. I pull in the construction data with the digital ticketing and everything else. And I pull in everybody's data from their own stuff to do it.
You don't know, in our own personal asset management, GAM, I don't know. I can't even begin to think of where that schema would be for that.
Well, but it may exist because other people may start to do it. So your construction group, right? If they start building in 3D CAD, then DIGGS can start to populate that data once we get the BIM IFC 4.7 schema or something, whichever one it goes into.
Yeah. Or if you slope management protocols, systems.
Yeah, we have a rating system.
And that's important. That's the present day value. But your question can't be answered yet.
Well, research thing.
Yeah, but maybe a point that we have to keep in mind is that the DIGGS or even the geotechnical data within DIGGS is not just captured at design stage. You capture it all through construction. You're probably going to go back and do some maintenance and capture geotechnical. Now you're starting to add data to it.
Right, but that's the idea. Still, the digital twin universe is the idea that your type of data can be incorporated at any time in the performance. When we were petitioning to be an EDC 7, one of the other data types to come in was roadway maintenance, lane closures, and other things, and operational data. But they had an XML protocol. But that was long after the project was constructed. But the idea was they would be using something similar to DIGGS to push in information about highway maintenance. And so, like DIGGS data that would come later would be the same thing. If we had
DIGGS for installing the piles during construction, or DIGGS for slope inclinometer readings for things that are going wonky with slopes. It still would use DIGGS because it's geotechnical, but it would come into that digital twin or that BIM MC product wherever in the entire life cycle it exists.
I would describe it as you can't have a GIS system if you don't have a uniform data structure to store all of your geotechnical
data.
Yeah, because it's not going to be possible to trend it. It's not going to be possible to find your history. Yeah.
So I think I'm hearing that the messaging on the site, we should start focusing more on applications and long-term uses of data to get people to start saying, yeah, I really need to have this now. I need the data.
Present value. Don't worry about my concept, my conceptual. That's long-term research. It's long-term research.
It was all present value.
This line, yeah.
You can do both things at the same time.
Yeah, Derek's side. Go back like 2 slides.
Not sure where you go.
This is before closing thoughts.
You're showing something else.
It's not changing for us.
It's not changing. Slow. Oh, I'm looking at the wrong page. Okay, sorry.
Click on the big screen.
All the drivers.
Yes, this
all
is all
the drivers.
Right. This is all true now.
Yeah, but I don't know that's a value of the data, but I think the fact that it goes into that BIM model brings, or that digital twin, brings that data through the life cycle, which is not present value, it's future value.
That's true.
And getting that message to be understood that you need to start here so you have it there.
That's true. But you've also got to have the drivers for reasons to do it today.
Right. And that's the selling point, right?
Yeah.
Nobody
It's not just
is
today.
going to buy off on Silas's no research.
Wouldn't it be great?
Who said no research?
Wouldn't it be great?
All right. Okay. So
no, research is a solution.
So I have about 5 minutes.
Yes, this was a good idea.
Threw this around. In 2019, we tried to do a student challenge, and it didn't go anywhere. Absolutely nowhere. So maybe we're not quite ready for it, but I would like us to start thinking about how do we start engaging the younger minds, the people that have vision and capabilities, to try to come up with something cool to do with it. We now have, that are free, but we have data. We can generate a whole lot of data now for them to work with, or maybe they can figure out how to generate a lot of data. And it would be good to maybe get a little task force together to start putting this together for next year's Geo-Congress or for something else that we can challenge people to do something cool with what we've accomplished so far.
I would be happy to contribute the data. We have all of the hundreds of thousands of, and I'd be happy to. I have tens of thousands of PDFs that are all structured and all in the same format that I would be happy to have some help on how to automate the extraction. I know that you've made
probably not going to happen.
I'm just putting out.
Because it's not about big work. So this didn't work in the past, and I have some suggestions.
Okay, sure.
So instead of, it's not an established challenge, right? There's a lot of things that you have to explain, and there's so things that have worked out in the past. Because I do this at Columbia University, we have something called a capstone project. So capstone projects are done in collaboration with companies, organizations, you name it. But there is an instructor who's driving it. So if there's a way to prepare a proposal that's not necessarily to the students, but it's project ideas to instructors. And let's look for instructors at universities who are willing to have data and a theme that they can present to their students and guide them through the process. instead of having it open-ended and be like, okay, students self-organize.
I agree. Yeah.
And do whatever you want, and we're here to help. That's not going to happen.
So maybe what we could do in the next few months is create a couple of those scenarios and package the data up, and then start looking for academics. Maybe we look for academics.
I would start talking to some academics already as we're
shocking. You're in a hotel.
As a senior in college, I feel like this would be my time to shine here. I am actively writing a senior thesis about the value of geotechnical data and how much we are losing every year. Like, yes. If anybody has, I mean, the scope of my thesis is not actually doing stuff with the data myself, but it's trying to quantify how much time do we waste by having administrators pull data from PDFs and searching local surveys, whatever. What can we use this value for? Or, you guys understand. So if you have data like that, if you're interested in talking about this, like, please reach out to me. I'm at all the DIGGS meetings quietly.
Glad you're joining us.
I'm also happy to help set up any sort of student challenge. I'll be graduating in May, but
who's your advisor that we can leverage again here?
He's actually here, but he does like operations. He's like driverless vehicle stuff. So I kind of convinced him to let me do something a little different.
Autonomous vehicles drive on roads and bridges. So.
Yeah, right.
Occasionally not.
They don't want to drive into a sinkhole.
That's right. Yeah. God, this is his 51st year. But anyway, happy to help anything related to this. And if you guys are interested in having a good number that you can start using and saying, hey, we're wasting X dollars per year as a country or as a state DOT, please reach out to me. I will put that analysis in my thesis.
It'd be very helpful to have that on the account.
All right. With that, I guess my time's about up.
2 minutes.
Oh, 2 minutes. All right. We got lots of time. Our GI friends all left. That's the only other thing I was going to try to focus on. We'd like to do something where we can work together in the exhibit hall or something, maybe get some GI or DIGGS floor stickers or something in front of booths that say we support DIGGS, and try to get a little more messaging out. You had some ideas about
this. Every relevant more than that sign is working with DIGGS. I think all the companies, manufacturers, whatever, that are contributing to this effort will be linked.
I think we're at the point now where we just need to let people know that it's more than 2 or 3 people trying to do this.
One
people are actually
comes and asks, okay, what is this?
Yeah.
Yep.
All right, so we're going to try to make that happen. So we will be in touch with everybody and anybody to try to support us with a sign or something. So, any other comments, thoughts, questions as we pack everything up and get out of here on time? I can't believe we got through this.
Excellent job. Yeah, well done.
Any comments out there in the hinterland? Thank you all for joining us and sticking with us for 3 hours.
Are you still there?
Somebody come live, go live and show us you're there. All right.
Hey, this is Peter. I've been listening for 3 hours. It was all very good.
Thank you. All right. Thanks, everybody. And we'll talk with you again next month and on the first Friday of the month at 10:30 a.m.
So
let me know if you're not on the invite.
We just need to. We'll create a simple example, kind of like we did with the MWD.
What was that?